Okay, this will be solving systems of equations using the elimination method. And when I don't have any guided notes for you, so please use a sheet of paper to write this down. You may even pause the video when you think you know it, so you can try or attempt a problem on your own. So elimination method is we want to eliminate a variable, an x or a y. And to do that, we need what is called additive inverses of each other, meaning the coefficient, the number in front of either the x or the y, when you add them together, cancel. They give you 0. So right here in this equation, or this problem, these two equations, this system, my coefficient of my x's are additive inverses of each other. So I can just go ahead and add these two equations to each other because 4x plus a negative 4x cancel. I get 10y equals negative 10. Divide by 10, divide by 10. Y equals negative 1. So my final answer, which will be a coordinate point, my y coordinate is now negative 1. Now to find my x. I need to use my y to find my x. You can pick any equation you want, and you will substitute that y value into that equation. So I'm going to rewrite the top equation, but instead of y, I am going to substitute negative 1. Line combine, move, isolate. 4x, 8 times negative 1 is negative 8, equals 20. I'm going to move everything away from my variable. Now I am going to isolate my variable, and I get 20x equals 7. So my solution is the coordinate 7, negative 1. So right here, I need to decide, do I want to get rid of my x's or do I want to get rid of my y's? Which one do I want to eliminate? Well, I am going to choose to get rid of my x's. But the problem is they are not additive inverses of each other. Because when you add negative 6 and negative 6, you get negative 12. So I need to change the sign of one of my equations. So I'm going to change the sign of the top equation. And the way you change the sign is you have to multiply through by negative 1, which changes the sign of everything. If you change the sign of one thing, you have to change the sign of everything. Now, I have additive inverses of each other, and my x's cancel. 3 minus 6y gives me a negative 3y, equals negative 12 minus 6 equals a negative 18. One step to get my y by itself. Y equals a negative divided by a negative is a positive, 6. So in my solution, my y value will be 6. Now I need to find my x value. And again, you can pick any of the equations you have. I know that y equals 6, so I am going to rewrite this bottom equation, but instead of y, I'm going to substitute 6 in. Negative 6x plus 3, instead of y, I put 6, equals negative 12. Negative 6x plus 18 equals negative 12. I'm going to subtract 18 from each side. Negative 6x equals negative 30. Divide both sides by negative 6. X equals 5. So now I have found my solutions, 5 and 6. Now here, again, I do not have additive inverses of each other. So I get to choose which do I want to get rid of. Do you want to eliminate your x's first, or do you want to eliminate your y's? It does not matter. I've been eliminating x's, so I'm going to go ahead and eliminate my y's first here. To eliminate my y's, I need to multiply the top equation by something that changes the coefficient to y to be a positive 7. Since the coefficient is 1, That'll give me a positive 7y. 7 times 5 is 35x plus 7y equals 63. So now I have additive inverses of my y's. So I add my two equations together. My y's cancel, giving me, or I have 10x plus a 35x equals 45x. My y's cancel. 18 minus 63 give me 45. I isolate my variable. I get x equals 1. So now I have the x value of my solution. I'm going to use my x value and substitute it into any of the two equations. Rewrite with my new x as 1. So I'm substituting 1 in for x to solve for y. Now I'm solving. 5 plus y is 9. Subtract 5, y equals 4. So my solution is 1, 4. And if you think you might be wrong, you may go ahead and plug them into each of the equations. Your solution must work for both of your equations. So now let's look at this system right here. I need to come up with an additive inverse. The problem is I can't just multiply by one number and one equation to get additive inverses. So I'm going to need to multiply both equations. First, I need to choose. Do I want to eliminate my x's or do I want to eliminate my y's? Again, let's go ahead and eliminate my y's. In order to eliminate my y's, I have a -2 and a -5. I need to make those the exact same number, the different sign. They need to be additive inverses of each other. So I'm going to go ahead and multiply this top equation by 5, this bottom equation by -2. I'm going to distribute to everything to give me 15x minus 10y equals 10. And then on the bottom, I'm going to distribute. I get -10x plus 10y equals -20. Now that I have additive inverses of my y's and they eliminate, I'm going to add my equations together. 15x minus 10x gives me 5x equals 10 minus 20 gives me -10. Divide by 5, x equals -2. So the x coordinate of my solution is going to be -2. And now to find the y coordinate, I am going to take that x and I am going to plug it in any of the two equations. It does not matter. I am going to substitute -2 in for x and then solve. Line, combine your like terms, so multiply or distribute, either way. -10 minus 5y equals 10. Move. So move everything away from your variable. Now I'm going to isolate my variable. Y is -4. And there is your solution. And again, if you need to check, you should always check by plugging your solution back into both equations because it must work for both equations. Same thing here. I need to pick which variable I want to eliminate. I'm going to eliminate my x's. And in doing so, I need to get my coefficients to be the exact same number, opposite signs. I know that 2 and 5, to get them to be the same number, that's going to be 10. So to make that that coefficient a 10, I'm going to multiply this by 5. And I am going to multiply this equation by 2. And in doing so, I get 10x plus 40y equals 30. The bottom equation, I get -10x minus 40y equals -30. I have additive inverses there. 40y minus 40y gives me 0. 30 minus 30 gives me 0. Does 0 equal 0? Yes, it does. So you will have infinitely many solutions. And now here, this final one, I want to eliminate one of my x's or my y's. I am going to eliminate my x's by multiplying by the top only by a -4. By multiplying the top only by -4, I get 4x plus 28y equals -20. So now when I add them together, my x's eliminate. I see that my y's also eliminate. 28 minus 20 gives me 8. Does 0 equal 8? No, it does not. Therefore, you have no solution. And that is how you solve systems of equations by the elimination method.